Okay, hello class, this is Miss Riggins, still at a coffee shop recording these videos, but today we're going to talk about dilation. And dilation is another transformation, but we haven't been dealing with the dilation transformation because the dilation transformation is not a congruence transformation. In fact, a dilation is not an isometry. And the reason why it's not an isometry is dilated shapes change size, but not shape. So here I have a lovely pentagon, and I'm going to dilate it. So this is my pre-image, and when I dilate it, the new shape is going to be my image. So let's take a look and see what the dilated shape is going to look like. So as we can see here, the pre-image is a lot larger than the image. So the shape did change size, but it didn't change the shape. We still have the same pentagon. And because this shape is, the image shape is based off the pre-image, if I were to change the pre-image, so would the image shape change because it's based off of the pre-image. So let's take a look at some interesting properties between two shapes, the pre-image and its dilated shape. So, as you can see here, the pre-image has the coordinates f, g, h, i, j, and the image has the coordinates f prime, g prime, h prime, i prime, j prime. So let's take a look at the side lengths and the angles. Do you notice any correlation between, any relationship between the corresponding side lengths? Well, as you can see, that the corresponding side lengths are different. There doesn't seem to be any corresponding side lengths that are the same. So therefore the corresponding side lengths are not congruent. Now let's take a look at the angles. What we can say is even though the corresponding side lengths are different, it looks like the corresponding angles are congruent. So that kind of supports our original statement, the dilated shape changes size but not shape. And we do have some type of relationship between the angles. The angles are congruent. Corresponding angles are congruent, but the corresponding side lengths are different. So because we have a dilation, we can see that the corresponding side lengths are different. But how different are the corresponding side lengths? Well, let's talk about, before we talk about that, let's talk about this number called the scale factor. The scale factor is a number S that is equal to dividing the image length by the pre-image length. And it's the number that I multiply the old length by, or the pre-image length by, to get the side length of the new image. So let's actually take our image length and divide it by the pre-image length and see what we get. So we took the image, which again is the new image, and divided it by the length of the old image. And what do you notice? For each corresponding side length ratio, we have that the ratios are the same. And this f prime g prime over fg is equal to 0.33. And that occurs for all of them. So we can say that the corresponding side lengths are proportional because they all have the same ratio when you divide the image by the pre-image. And in this case, our scale factor is 1/3 or 0.3333. So what does that mean? That means if I want to find the new side length, all I have to do is multiply the original side length by 0.33 or multiply it by 1/3. So let's say, here's my original side length, FGG. Let me make it FGG a bigger number. Let me make it 6. So if FGG is 6, what is F prime G prime going to be? Well, all I have to do to figure that out is to take 6 and to multiply it times the scale factor. So 0.3333 times 6.01 is going to give me, any guesses? A number very close to 2, because 6 times 0.33 is 2. In fact, that's going to be the relationship between all the side lengths. If I want to figure out the new side length, or f prime g prime, all I have to do is multiply the original side length by 0.333. As you can see, 3.35 times 0.33 will give you 1.12. 4.29 times 0.33 will give you 1.43, and vice versa. So the scale factor tells you what number to multiply each of these numbers by, so you can get the resulting image length number. Now, what if I had started with, instead of this being the pre-image, what if this was the pre-image? And instead of this being the pre-image, what if this was the image? So what number would I multiply this by to get to this shape? Would it be 0.33? Well, no, because 0.33 makes it a smaller figure, and we can see to go from here to here would be a larger figure. So what number do you think when I divide the new by the old? Let's see what it will be. It seems like it's going to be 3, which makes sense. So 2 things I want you to note when dealing with dilations and scale factors is, if s is less than 1, the image is smaller. If s is greater than 1, the image is larger. If s is equal to 1, the image is the same. And in order to figure out what s is, you have to divide the image by the pre-image length to be able to figure out what s is. And it doesn't matter which pair of corresponding sides you use, because you will always get the exact same answer as long as they're corresponding.